Hello, welcome. Today we will be working on factoring special products, primarily factoring perfect square trinomials and factoring the difference of two squares. Let's begin. So let's start with the perfect square trinomials. In order to factor perfect square trinomials, you must make sure that the first and last terms, are perfect squares, such as numbers like 4, 9, 25, and so on. At the same time, the middle term is 2 times one factor from the first term and one factor from the last term. So let's see what these mean. Alright, so in general, our perfect square trinomials are in the form a squared plus 2ab plus b squared. The factored form must be in the form a plus b, quantity squared, or a plus b multiplied by a plus b. Let's start with this example. So, remembering that the rule mentioned to check if the first and the last terms are perfect square numbers or expressions. Take a look at x squared. You can get the square root of x squared, and the factors must be x multiplied by another x. Similarly, your 9 will have factors of 3 multiplied by 3. If that's the case, the second qualification must be that the middle term should be twice of each factor from the first and the last terms. So 2 multiplied by x multiplied by 3 must result in a positive 6x. In this case, it does. So now we can go ahead and make sure that our factors will show a perfect square trinomial. In this case, it must be in the form where a represented by your x and your b value represented by 3. So I can write the factors of the given trinomial in this manner. Or, if you prefer, x plus 3, quantity being squared. Alright, let's try another one. This time we'll work with a trinomial in the form of a squared minus 2ab plus b squared. Alright, let's take a look at our given expression here. Let's go ahead and check if our first and last terms are perfect squares. I can go ahead and check that x squared is x times x, and a 1 is a 1 times a 1. Perfect. Now let's check our middle term. So we say we multiply by 2, the first term's factor, and the last term's factor. In fact, it must result in our middle term. And in this case, it absolutely does, with the consideration that it's a negative 2x. So we can now go ahead and write our factors down as factor from the first term minus factor from the second term, and once more, factor from the first term minus from the second term. Again, x minus 1, quantity squared. Alright, let's do a couple more. So this time our leading coefficient is no longer a 1. So let's see if we can still check if these are perfect square trinomials. Could you get the square root of 81x squared? Yes, you can. That will give you a 9x multiplied by a 9x. On the other hand, your 25 will have factors 5 multiplied by 5. Let's go ahead and check our middle term. Will this result in a 90x if we multiply 2 by 9x by 5? Go ahead and check for me. Yes, it does. And because it does, we can go ahead and write our factors as 9x plus 5 quantity squared. Awesome. Let's do the other one. So let's go ahead and check if we can get the square root of the first term. Same thing with the last term. Alright, let's go ahead and move to the middle term. I must get a 12x by multiplying 2 by 3x by 2. What do you think? Yep, there you go, you'll get your 12x. In that case, factors must be 3x plus 2 quantity squared. There you go. Alright. Feel free to pause the video at any point we'll go forward with a couple more examples. Alright, start again by checking if you can get the factors of 9x squared, showing that they are perfect, and so with 64. Okay, alright, our middle term must result in a negative 15x. Let's see, is twice of 3x and 8 going to result in negative 15? Definitely not. So in this case, we will solve for a 48x, which is definitely not equal to negative 15x. In this case, we can say that this is not a perfect square trinomial. Alright, let's go ahead and check the next one. Correct, 6x and a 6x. And, well, what can you say about 14? Exactly, 14 is not a perfect number. So because it isn't, then this is not a perfect square trinomial. So that's how you can identify a perfect square trinomial. Good job. Let's go forward. Now to a word problem. A square piece of cloth with an area given 16x squared minus 24x plus 9 square inches. Our objective is to find an expression for the perimeter, and then find the perimeter when x is 11. Let's begin. First of all, you have an area of a square, a piece of cloth, which for sure you should be able to determine from here that a square has equal measures across its 4 sides. If so, then the area given for us can be simplified to have factors of 4x minus 3, quantity squared. So it means that every single side right here measures a 4x minus 3. If so, right? If so, then the perimeter, as we all know of a square figure, is 4 times all its sides. Or in this case, is 4 multiplied by 4x minus 3. And this is what you mean when you say find an expression for the perimeter. Now that we have an expression, let's go ahead and find the actual perimeter when x is 11. Alright, let's go ahead and plug in 11 for x. So I'll have a 4 multiplied by an 11 and a minus 3. Let's simplify further. I'll have a 4 and a 44 minus 3. Continuing on, I'll have a 4 multiplied by a 41, which I must result in 164. So then we say the perimeter when x is 11 is 164 inches. And that's how you can find the perimeter when you are provided with an area. Again, you can always pause and replay this part of the video as needed. I'll go forward. At this point, we were able to go over perfect square trinomials, and now we will work on the difference of two squares. The difference of two squares is represented by a squared minus b squared, which would have factors of a plus b multiplied by a minus b. If you remember, in one of our previous lessons, this was actually given to us as factors of difference of two squares. So now, our objective is to check if a given difference of two squares is actually a difference of two squares. First of all, powers on the variable terms, alright, must be even. So meaning I should be able to divide them by 2 easily. Another point is that the constants are perfect squares. So like the coefficients, they need to be perfect squares at the same time. Let's take a look at an example. Alright, so first of all, we were supposed to check if our variables can be divided by 2. And in this case, yes, it can be. So then I should be able to break down x squared into x and x. Following our loss of exponents, each x will have an exponent of 1, adding up to 2. Similarly, your y should be able to be broken down into y and y. Perfect. So that's half of our qualifications. Now let's go ahead and check our constants. In this case, the first term has 100. Could you get 100's square root? In fact, you can. It's a 10. And could you get the square root of 4? And it's a 2. So if that's the case, we've checked the qualifications and it passes perfectly. Now we can write our factors down, remembering that it's in the form of a minus b multiplied by a plus b. In this case, your a represents a 10 and the b represents a 2. Oops, we forgot the x. On the other hand, we'll have a 10x plus 2. And here are the factors of the given difference of two squares. Again, you can always check by multiplying them back to be sure that you have factored correctly. Let's go try another example out. Could I split p squared evenly? Yes, that's a p and another p. Q to the fourth should be a q squared multiplied by another q squared. Alright, now let's take a look at your constants. Could you get the square root of 3? Exactly. No, you cannot. And because you cannot, then this is not a difference of two squares. Alright, so that's one way you can check and make sure that your given expression is a difference of two squares. Alright, let's try a couple more examples. Alright, in this case, I have an x to the fourth minus 25y to the sixth. I should be able to split x to the fourth perfectly fine. Y to the sixth should be split between y cubed and another y cubed. Alright, can you possibly get the square root of 25? Well, of course you can, and it exactly is a 5. Well, what's the coefficient of x to the fourth, if you ask? It's not there, but you should know that it is an understood 1. Just a 1. Alright, and because it passes your qualifications, our factors must be x squared minus 5y cubed and x squared plus 5y cubed. Now, does it matter if I do the subtraction factor first or the addition factor? Not really, as long as you have both signs present to show it's a difference of two squares. Alright, let's try the other example here. I should be able to split p to the 8th as p to the 4th multiplied by a p to the 4th. And q to the 6th is a q to the 3rd and a q to the 3rd. And the square root of 49 is 7. So if that's the case, it passes once again as a difference of two squares. Our factors must be p to the 4th minus 7q to the 3rd. That's a 3. And a p to the 4th plus a 7q to the 3rd. And there you have it, folks. Please let me know if you have any questions.